Welcome to the fourth of 6 webinars focusing on effective mathematics teaching. Now, this webinar will focus on units of measurement. My name is Tracy Hughes-Butters and I'll be facilitating this webinar, which has been designed to consider students' errors in the PAT Maths assessment, focusing on units of measurement and what we as teachers can do to support our students to ensure that they are able to demonstrate their mathematical skills and knowledge competently and confidently in unfamiliar situations. From the PAT Maths data, there are 5 areas of concern that have been highlighted for our students in Catholic schools. Now, please note, they're not in any order, so this webinar will focus on the third dot point, using units of measurement. So there are 4 questions that we will unpack, and each question targets a different year or stage level. Please pause and read the learning intention and success criteria for this webinar. Now, we do need to consider the enormity of the topic units of measurement and note that we cannot effectively cover everything in a half-hour webinar. So we will draw from the PAT Maths data and analyse a series of sample questions that are similar to the questions that had the lowest achievement rate. Now, the sample questions will vary from years 1 to 6. I will lead your team through a set of focus questions that will identify the prerequisite knowledge, key concepts and skills necessary to access the question. We will also analyse the common errors and misconceptions that could impact student choice. And then finally, we will reflect on our teaching. What is supporting our students' learning? What could be changed, adapted, or added to improve our students' learning experiences in mathematics? And there will be plenty of time for discussion and reflection. I have designed a set of 4 focus questions to prompt discussion and reflection. Focus question 1 is to ensure that we, the teachers, understand the key concepts and skills that the question is actually assessing. Focus question 2 will consider the prerequisite knowledge and skills that our students must have to attempt the question. Focus question 3 is to consider why our students may have decided on an incorrect answer due to common errors and misconceptions. Focus question 4 is what can we ensure our students experience in their learning so that they are able to experience success in this style of question. Now, I will present 4 multiple choice questions in the webinar. Simply fast forward to the year or stage level that you would like to analyse. However, I would recommend that you complete the first focus question and at least one other question in the time, and not just target the questions that your students would be attempting. We need to know the big picture here, not just one part. Ensure that someone is scribing, and I would recommend a whiteboard with different coloured pens. Discuss and add to the board as you work through each focus question. And when you're finished, take a picture of the whiteboard and recommence the video. Now, from the PAT Maths data, our students across all year levels appear to struggle with the concept of time. So let's analyse this question and consider why our students find time such a challenging concept. Please read the sample question. Pause the video for approximately 5 minutes to consider and discuss the focus questions. Ensure that someone is scribing, and when you're finished, recommence the video. The key concepts and skills that this question targets is finding the difference between AM and PM time. So what are the prerequisite skills and knowledge? Well, it is simply the duration of time. So let's work through each distractor in this question. 1 hour. Well, students may have found the difference between the 2 numbers, 7 and 8. 7. Calculated the time after midday, but forgot to add on the 4 hours before midday. 9. Subtracted the 8 from 10 rather than 12, and then added the PM time. 11, of course, is the correct answer. So in summary, the question depended heavily on the student's ability to understand 12-hour time and confidently apply their understanding to word problems such as this. Please pause the video and discuss. Time, especially the duration of time, can be problematic with some students. So based on the analysis of this question, I would suggest the following. 1. Ensure your students have a deep understanding of 12-hour time and are equipped with the skills to apply their knowledge in word problems. 2. Practicing processing the question efficiently and accurately. For example, as a class, work through word problems using guiding questions such as, what do I know? So what is the information given in the question? Is it as simple as asking the students to restate the problem in their own words? What do I want to know? Well, what do you need to find out? Clarify the necessary information. What do I do to find out? So what strategy could be used to calculate the answer? Is there another strategy that could be used? Now, a very powerful learning experience can be nurtured here. Encourage your students to compare strategies with others. What's the same about the strategy? What's different? This process of sharing and discussing strategies is integral in developing students' mathematical thinking and problem-solving abilities. And of course, finally, does the answer make sense? How do you know? How do you check your answer? Go back to the problem. Does the answer make sense in this case? Active talking is a powerful learning experience that aids students to strengthen and deepen their mathematical understanding. When students listen to each other's strategies and processes, it dispels that myth that there is only one way in mathematics. It also has the added benefit of improving memory and sense-making, as well as valuing thinking of others in the classroom. There must be time spent on modelling the 4 questions by the teacher. They are powerful prompts for developing skills in interpreting word problems. Model and practice them with your students. Do less word problems and spend more time discussing the 4 questions to develop your students' confidence in attempting a word problem. Bring it back to a pictorial or concrete format and use a 24-hour timeline such as this. It models the calculation of elapsed time. So students start by marking in the start and finish times. Also mark in any 12-hour markers that occur between those start and finish times. Students then draw jump lines to each marker and write in the time duration for each. The diagram then represents the operation to calculate the total duration, in other words, addition. The power of the diagram is to clarify the word problem. Extending this, students can join their day timelines together to represent a set of days to complete word problems such as this. So place the strips on a mini whiteboard and students then can add to the diagram information that would clarify their understanding of the problem. The start and finish times, the relevant 12-hour markers, and then of course add the jump lines to each marker and use the diagram to decide on the most appropriate operation to calculate the answer. Again, students will only continue to use these types of learning tools if they are valued by the teacher. So ensure that they appear in assessments and you use them in your explicit teaching and modelling. Pause the video to discuss what you currently use and the advantages of using a day timeline. Here is an example of a question targeting Stage 2 or Year 3 and focusing on the correct reading of an analogue clock and calculating a time, given the difference between this time and a target time. Now, in the PAT Maths assessment, only 34% of our students were successful in attempting a similar question. Carefully read the question and then consider and discuss each focus question. Ensure that someone is scribing. And when you're finished, please recommence the video. Well, welcome back. Let me present my thoughts on each of those focus questions. So, starting with focus question 1. Well, the key concepts and skills necessary to successfully answer this question would include 1, reading and interpreting an analog clock, and of course 2, calculating a time in a word problem. Now, this style of question may be challenging for some students. They may struggle to demonstrate their understanding of time simply because they cannot find an entry point. Prerequisite skills for this question would include calculating time to the hour and time duration. Now, working through each distractor in this question. Well, of course, A is the correct answer. B, students may have found the time 20 minutes past the previous hour, that is 10 o'clock. C, well, they may have found the time that is 20 minutes past 11 o'clock. And D, well, they just may be unfamiliar with reading an analog clock face, or simply decided on a different time to those presented, or even been taught to always click on the answer that says none of these. Pause the video and discuss the slide. Now, time brings in a whole new set of concepts. Students who have learned to count in base 10 linear scales that have a baseline 0 are now presented with 3 connected linear scales, the hours, the minutes, and the seconds. And to add to the confusion, they must be able to interpret both analog and digital clocks that may or may not include 24-hour time. Throw in an array of different phrases to describe the same time point. For example, the first clock face on the screen could be read as 20 to 11, 10:40, or even 40 minutes past 10, 10:40 a.m. or 10:40 p.m. or even 10:40 or 22:40 hours. You quickly understand why so many students struggle with the concept. Now, at this point, we must also consider how technology has imposed itself on our real-life mathematical practices. The number of ways of describing time has reduced as technology uses digital clocks over analog, and more often, descriptions of time are accurate to the nearest minute. For example, if you ask for the time, the answer is often given as, it's 11:47, rather than, just after 11:45. We've become a lot more accurate. Based on the analysis of this question, there are 2 focus areas: point of time using an analog clock and calculating time periods. Let's start with analog clocks. Now, analog clocks need a considerable amount of background knowledge in order to be read, such as, the hands on a clock rotate. Now, don't chuckle, because this could be the blocker for your students. An activity as simple as observing a clock as it moves and asking, what do you notice? What do you wonder? What's happening? It will promote so much discussion. Presenting a static clock does not demonstrate the mechanics, such as the big hand travelling 1 revolution as the little hand moves to the next number. Observing a moving clock demonstrates the cyclic nature of time. Now, some students will not understand that 7 o'clock, for example, occurs twice in one day. Identifying the hour hand and determining its value based on its position is quite important. Now, one effective visual is shading the segments as presented on this slide. The different colours may aid students when identifying where the hour hand occurs. Observing a clock moving also demonstrates that the minutes linear scale is layered on top of the hours linear scale. So when we are tracking the minute hand, though there is the number 1, it actually means 5 minutes, and 2 means 10 minutes, and so on. Simple? Well, not for some. You must consider whether your current teaching methods for time, such as manipulating clock faces and word problems, will develop your students' understanding. Is there considerable connection in the classroom between the mathematics of time and the students' world? Look, this is crucial if you want your students to understand the concepts. We do know that most students intuitively understand concepts of time as they are immersed in a timed environment, and schools are such an environment. So word and corresponding image schedules of school activities can support student understanding. Now, this includes the vocabulary of time and the use of children's literature based on time. It's a very effective tool for developing understanding, as long as discussion occurs throughout and after reading of the book. I would suggest that as students learn to read clocks and tell how much time has passed, they should also be encouraged to think about the relative length of that time interval. Is it a short or a long length of time? Connecting it to familiar situations may aid students in calculations of time periods. So why is time such a challenge for so many of our students? Well, unlike the number system, in time, there isn't a placeholder such as 0 is on a number line. In fact, 0 appears to be replaced by 12. And unlike other units of measurement, time is abstract. You cannot physically pick up any of the units. Now, this makes the concept quite challenging for some students. So let's make it concrete. Let's get your kids to build a clock. So begin by creating the 2 linear scales in a straight line. Begin with the hour scale, 1 to 12, and then separate each number with 5 blocks to represent the minutes and add the minutes count under the hour numbers. Now, after lots of discussion on what students notice about the 2 scales, transform to a circular format, a clock. Place the minute count numbers under each hour number to reveal the associated number of minutes. Now, this practices and reinforces multiples of 5 and skip counting by 5 and demonstrates the connection between the hour number and the minute number. Now, the placement of the minutes under the hour numerals also reinforces the need to know the hour value before the minute value. Now, building this clock can also demonstrate, practice and reinforce geometry and fraction concepts and skills. The second area of learning is duration of time. Now, there are 3 components of duration of time: start time, end time, and of course, duration of time. Students must be able to competently read a clock face and also calculate the time span. Now, connecting the learning to familiar situations may add sense to students' learning. So consider this stimulus. The question is, my baby brother has a nap in the afternoon. How long did he sleep? Ask students, what do you know? How do you know that? Can you calculate the answer? And how could you work the answer out? Allow students time to discuss and as a group share their findings and discuss any different successful approaches. Most students have experienced questions where they know the original time and the target time, and then they calculate the duration. Well, the other common form is, given the original time and the duration, calculate the target time. But this question challenges students' interpretation skills as the target time and the duration are given to calculate the original time. Pause the video and discuss the learning strategies presented. Now, here is an example of a question targeting Stage 3, Year 5, focusing on capacity and reading and interpreting scales. In the PAT Maths assessment, only 44% of our students were successful in attempting a similar question, which, when you consider the question and the year level, is concerning. Pause the video and carefully read the question, and then consider and discuss each focus question. When you're finished, recommence the video. The key concepts and skills assessed in this question include units of capacity and the reading and interpreting of a scale. Understanding that the gradations, the marks, show the end points of units, including 0 units, and all scales have a placeholder, the origin or baseline, 0. Though, as in this example, the number 0 is not displayed on the jug. The prerequisite skills and knowledge would be the informal measurement of capacity and number lines. Let's work through each of the distractors. The first one. Well, students have assumed each gradation represents a unit of 1. They have applied a 1-to-1 correspondence to the scale. 410 millilitres, well, the students have assumed each gradation represents a unit of 10. They may be confusing the unit measure with centimetres. 425 millilitres. Students may have assumed that each gradation represents a unit of 25 because there are 4 gradations between each of the marked numbers and that, incorrectly, the difference between each written number is 100. 450, of course, is the answer, and none of these, they just don't understand scale. Pause the video and discuss the distractors. Students must be explicitly taught how to read and interpret linear scales using a variety of measurement instruments. They should understand that all units of measure are a part of the attribute that they measure and that the units are all the same size. Now, students should have multiple opportunities to read an assortment of scales, dials and meters, and discuss and share approaches and strategies. These readings should be both from the actual instruments and images. So, to build on students' understanding of scale, there should be opportunity for students to select the most appropriate scale suitable for the necessary measurement, such as constructing scales on an image of a measuring tool is a very powerful learning experience. It builds an understanding of the structure of scales. So, give your students minimum information. So in this case, we have an image of a jug with 1 litre and 100 millilitres labelled. Direct students to calculate the capacity of the jug, justifying their answer. Allow them time to think, discuss and strategise before implementing their approaches. Now, when completed, allow peer evaluation and then as a group discuss the approaches and challenges. And then present another jug with different minimal measures and fluid amount and challenge students to accurately measure the fluid content with justification. Pause the video and discuss how this type of activity could build understanding when applying scale in measurement. This is an example of a question targeting Year 5, focusing on the comparison of areas of compound shapes superimposed on a grid. Now, in the PAT Maths assessment, only 26% of our students were successful in attempting a similar question. Carefully read the question and then consider and discuss each focus question. And when you're finished, recommence the video. Now, the key concepts and skills targeted in this question include identifying the attribute to be measured, that is, area. Kids so often confuse area with perimeter. Calculating the area of a shape by counting squares, comparing the areas of compound shapes, and conservation of area. The prerequisite skills and knowledge for this question include sorting and matching 2D shapes and counting the unit measures. Ensure that your students understand why the unit of measure is a square. And why is that? Because squares fill a flat space with no gaps or overhangs. Well, errors and misconceptions could include A. The students may have counted each part as a whole square, so they do not understand the need for a standard unit of measure. B, of course, is the correct answer. C, students may think that as the shape is the tallest, it must have the largest area. So they have confused the attribute of length, not area. D, students may think that the shape looks larger due to the width and height of the shape, but they have not considered that it is triangular. And E, well, students again may think that the shape looks wider than the others and have connected it with the largest area. Pause the video and discuss the distractors. We must ensure that our students understand that area is an attribute of shapes, and for that matter, objects. Now, the concept of area must be explored in different contexts to ensure that students understand the difference between perimeter and area. If we ask our students which is the larger, There may be misconceptions, with the most common being applying the characteristics of perimeter to area and vice versa. So we must explicitly teach the concept of area and the conservation of area after investigating both. Check that your students understand that the unit of measure must always be the same if you want precision, and that you can have partial units that can be described in fraction form. And students must also understand that units of measure can be partitioned and joined, which then applies addition and subtraction of fractions, such as 2 half units make a whole unit. Now, the conservation of area is an extremely important concept. Do not underestimate the problems your students will experience if this concept has not been explicitly explained and considered and investigated. To develop understanding, students should have hands-on opportunities to estimate, investigate, discuss and explain the conservation of area. Do not isolate or neglect the practice of recomposing shapes, partitioning and joining in your students' learning. A simple but very effective activity is using a basic shape, such as a rectangle, and cutting it to form a new shape, observing that the area stays the same. Now, a transparent overlay of square units will aid the demonstration of this and joining the partitioned units. Pause the video and discuss. Extend this activity to more complex shapes. Partition and join units to create a whole unit. Allow students time to discuss, experiment, and then cut out and join their partitions. Another easily accessible learning experience in developing students' understanding in the conservation of area is the use of tangrams. But again, students should be cutting the pieces out and rearranging them into different shapes. Discuss the conservation of area and the possible reasons that some may think that the shapes created by using all the tangram shapes have a different area, especially shapes such as the rocket, because students again will confuse length with area. That is, the rocket is the tallest, hence it is the biggest. Discussing and clarifying such common errors with students builds understanding. Well, this webinar has certainly made me reflect on my practice. The questions that we unpacked confronted me. Our students have struggled with the concepts of measurement. Now, as I stated in the beginning, we cannot begin to triage measurement in one short webinar, but we can reflect on the following. Can our students successfully identify the attribute? Do they understand the difference between attributes such as perimeter and area, volume and capacity, minutes and hours? How can we ensure that we do justice for all attributes within the concept of time? I mean, it has so many attributes. What strategies can we provide to develop understanding? Do our students understand scales on measuring tools? Do we give our students opportunities to read many different scales on a variety of measuring tools before presenting pictorial representations? Do our students understand partitioning and iterations of units when measuring? Are we developing learning experiences that allow our students to partition shapes, count units of measurement? And finally, how can we ensure that our measurement lessons do not become number lessons and our students are engaging in measurement? Every measurement lesson should include the actual process of measuring, not just calculating. And finally, did we hit the mark? Well, here is the success criteria for the webinar. Discuss them with your team. What can you employ in your classroom to support your students' learning? Thank you for joining me today.